Children, we had two different ways we could do it. One was substituting things in, one was graphing. Today, in your notes, is elimination. Okay? And elimination basically is based on this thought process. Take a look with me and see here. Well, maybe not. Sure, no. Let's just look at a problem here. Look at problem number 1 here. Okay. What do you suppose? What do you suppose when you hear the word elimination? What do you suppose we're trying to do here? What's that?
Eliminate.
Very good. We are trying to get rid of one letter altogether, right off the proverbial bat. Okay, and I will show you what that means. If I can find the little thing. Oh, look at it, it's right there. Okay, take a look at this set of equations here. What your goal is to do here is by adding or subtracting, do you not have one? By adding or subtracting the two equations, you want a letter to disappear. Well, to disappear. This is not a good start to the okay. If you look at this right here, children, check this out. Here is elimination at its easiest form. I am going to combine both of these equations. Notice how the x's line up, the y's line up, and the numbers line up. Okay? If I take a negative 3x and add a negative 2x to it, what do I get? Negative 5x. If I have a positive y and a negative y, what happens? They're gone. You get 0 y's, there's nothing there. If I have a negative 12 plus a negative 3, negative 15. And by adding those two equations together, the y has been eliminated, and I only have one letter that I can now solve for. How do I solve this new equation? Just divide by negative 5. X has to equal 3. And you are pretty much done, except for you need to figure out what y equals. How do you suppose I'm going to figure out what y equals? Just like before, you need to go back to the original equation and substitute it in. You need to go back and find the other variable. And again, this is where a lot of people go wrong. In this case, it really doesn't matter which one you pick because both of them are going to require a little bit of work. Let's just do the first one. Negative 3 times what we figured out x to be plus y equals negative 12. I just took my answer for what x is, put it in for x. Now I need to solve it to see what y is. Negative 3 times 3 is a negative 9 plus y equals negative 12. Add 9 to get it to the other side. Add 9 to negative 12, and I end up with y equaling a negative 3. Correct? Negative 12 plus 9 is negative 3. And there is, children, solving by elimination. A little easier than substitution, I would say. A little quicker. Now, that doesn't mean it doesn't get a touch bit harder here. Let's do one more like this, and then we'll talk about when it gets harder for right now, I hope. Okay. In order to be able to do this, take a look up here. Don't get too far ahead of it. In order for this to work, what has to happen is you have to have x's or y's that are opposites of each other. Okay? In other words, when you look at the two equations, this only works. Here I have a negative x and a positive x. Those are opposites, so when I add them, they're going to go away. If this would be a negative x and a 3x, when I add it together, it's not going to go away. but in this case it does. The y's aren't going to go away, they're going to stay. So in this case I can just add them together. Negative x plus x is no x's. 6y and y is 7y. Negative 5 and 5 is 0. I can divide by 7, I can divide by 7. 0 divided by 7 is y equals 0. And this one will be pretty easy because if you put 0 in here, what number plus 0 is 5? X is going to have to be 5. Sorry, I don't know why I wrote 3. X is going to have to be 5. And right now you're saying this can't be as easy as it is, and you are right, because if you look at, let's just jump right down to number 4. If I were to add those together, boys and girls, nothing is going to go away because look, I add this together, it's negative 6 and a negative 7 is a negative 13x, negative 3 and negative 3 is a negative 6y, and this is 39. Don't work there. But fortunately for you children in math, there's a little thing that says on the multiplicative equality property of equations, which says you can change these as long as you change all of them the same way. In other words, multiply them all by the same number, divide them all by the same number, not add or subtract, only multiply and divide. So, let me ask you a question, and there's a couple right answers here. How can I get a letter to be opposite of another letter? What would you do to what, Jake?
Well, you need to change the sign to this.
You can as long as you change all of the signs of all of the things. And then, because that's the same as multiplying everything by a negative. So Jake says, can't you change that to a positive or that one and it wouldn't matter? Yes, you can, but you have to do everything in that. In other words, I'm going to multiply all 3 of these by negative 1. Okay, which is going to make this be a positive 7x, positive 3y, negative 21. Okay, when I put these together, I end up with a positive 7 and a negative 6. I end up with a positive x. The y's go away. Over here I have a negative 21 and a positive 18, which gives me negative 3. Shabam! X equals negative 3. Once you get the negative 3, doesn't matter which one of the 2 equations or the 3, whatever one you do, you're going to have to substitute that in for x. Negative 6 times negative 3 minus 3y equals 18. This is a positive 18. You subtract that from 18, you get 0. So y is going to equal 0. Let's look and see what this one had here. I gotta look at your homework maybe before I go any farther with this, because it might be something. There may be something that I have to go over. Yes, ladies and gentlemen, let me give this to you because we have to talk about this. Only because you're smarter than most of the 5th graders this year. We will forge ahead to this. Take a look, if you will, please, at problem number hey caramba, problem number, let's just say 11. No, let's not say 11. I'm going to change my mind on that one. Problem number 9's easy. Yeah, okay, let's do that. I'll do this in big, bold, beautiful things here. Here's problem number 9. I'll write it up here. Again, you won't do this on that piece of paper because that would just be wrong. 20x plus 20y equals negative 30. And then you have 10x plus 10y equals negative 20. Okay, we're trying to solve these by elimination. If you look at that, ladies and or gentlemen, You add them together, you're just gonna get a whole bunch of gobbledygook. You're gonna get 30x, you're gonna get 30y, you're going to get negative 50. Okay? You need to try to manipulate these two equations so that when you add them together, one of the letters will go away. So you have to sit there and look at this. Well, in order for 20x to go away, what would x have to be on the bottom? Negative 20, because the 20 minus 20 goes away. Or in order for a 20y to go away, what would the bottom have to be? Negative 20. Okay, so you need to, who picked this one? Ryan. All right, let's do it anyways. So you are your own boss here. What, if I wanted this to be a negative 20x, what do I have to multiply this by to get it to be a negative 20? Negative 2. So I'm going to do that. I'm going to multiply everything on the bottom by negative 2. So I end up, I'm changing my bottom equation to be negative 20x minus 20y equals, whatever it is, 2 times that, positive 40. Now, the reason I didn't like this as we got into this, because what happens? Both of them go away. You get nothing equal to 40, which means what's that? Which means, are they the same line?
Yes.
Well, in order for them to be the same line, this is half of that, that's half of that, this is not half of that. Okay, they're not the same line. Okay, if they were the same line, that would be infinite solutions. This you get 0x minus 0y equals 40. That's no solution because you can't do that. Because you'd end up dividing by 0, and you can't do that. In other words, these lines here are parallel, if you were to graph them. So thank you for whoever suggested we do that one. Let's find another one. How about 12? Let me do 12. Negative 2x plus 3y equals 25, and 9x plus 9y equals 0. Okay, again, in elimination, you are looking for how will the letters, or what can you do to them to get them to go away. So if I have a negative 2 here, in order to get x to go away, I'd have to have a positive 2 there. That doesn't look very easy to do. If I look at the y's, I have a 9y on the bottom. What would the top have to be to become to get it to cross off? Negative 9. How do I get 3 to become a negative 9? Multiply it by. So that means I need to multiply everything by a negative 3. Which means you're going to end up with 6x, correct? Negative 3 times negative 2, minus 9y equals negative 75. Now you take a look at these two equations. Did I do something wrong?
Could you divide the bottom by negative 3?
Yeah, you probably could have. You'll probably get the same answer. The problem is dividing 0 by 3, but you can do that, it'd still be 0. I think you'll get the same answer, yes. Multiply or divide. So 6x and 9x is 15x. The 9y and the negative 9y go away, and then you have negative 75 equals 0, which gives you a negative 75, and you put that with 0. Divide by 15. X is going to equal negative 5. Put negative 5 in here. For x, you get negative 45. Add it to the other side, you get positive 45, and divide by 9 to see what y is. Y is going to equal a positive 5. You may have to do that off to the side and not quite such a crazy thing. You want me to do that all over again? How about you, right now, problem number 8. See if you can't do problem number 8. See how far you get with problem grade. And I know this is good, so we'll give you a little leeway on this. 7x minus 7y equals 28, and 14x plus 2y equals 24. Again, you just have to look at those numbers and say, how can I get one of those letters to go away? What would I have to do? What would I have to do to them to get them to go away? And you have multiple choices, either by multiplying or dividing. Those are your two choices. You can't add or subtract. You can't add everything to something and subtract it. It has to be multiplying. You got answers, Houston?
Oh, no.
Again, don't come complaining to me if you try to squeeze it in on a worksheet paper. You can complain if you're Jake who's trying to do it on a big piece of paper like he should. And the question then would be, more than one way to skin a cat. Michael, what did you try multiplying by what to get what to cross off?
I tried multiplying the top by -2.
I would concur to that. Multiply everything on top by -2. Not the only way to do it. I'm going to rewrite this whole thing over here, just so I know. That's going to equal -14x plus 14y equals -56. Correct?
Yeah.
This one on the bottom stays the same. It's 14x plus 2y equals 24. My x's do go away. 14y and 2y is 16y. -56 and 24 ends up being 32, a -32. Divide by 16, and it's always a good thing when they work out evenly, because that's a pretty good indication you're on the right track. Y equals -2. And it doesn't matter what of the equations you put that -2 in for y. I'll go back to my original one. 7x minus 7 times what y is, -2, equals 28. 7x plus 14 equals 28. Subtract 14, you end up with 7x equaling 14, divide by 7, divide by 7. X then equals a +2. Stop me there if you got questions. Why did something happen? You have to be very, very, very accurate when you do this. One little goof up on one place with a negative or a positive and things come crashing and burning. Hence the reason why get a big piece of paper, do it out nice and bigly. Don't try to cram stuff in a small thing. Organize your thoughts. Keep situated there. We should probably try, let's try one story problem just for fun. Flip the page there. 17, 18, or 19, Ariel, pick one. Don't look at them, just randomly guess. Just give me 17, 18, or 19. 18 says, Stefan and somebody are selling flower bulbs at school for a fundraiser. Customers can buy packages of tulip bulbs and crocuses. Steph sold 4 of tulips, 4 of crocus for a total of 104. What's the first thing you're supposed to do, Alex? Define your variables. What are my variables? I am going to use, the letter T is going to be what? How much tulip bulbs are. And the letter C is going to be the cost of crocus bulbs. So then my two equations are going to end up what? It says 4 of tulips and 4 of crocus is how much? 4 tulips, 4 crocus is $104. Stop me if that doesn't make sense because it says it right there. The second one says 4 of tulips and 3 of crocus is $89. Logically, you could probably figure out what the cost of this is, but hey, why not? Let's just figure it out. Solving that by elimination couldn't get any easier. Well, it could get a little easier, but how am I going to fix that, Evan? Because right now, if I add them together, nothing goes away. But if I do what?
You could subtract.
Well, I need to change them all to their opposites. This needs to be a -4, that one. It doesn't matter which. Let's just do the bottom. Change this to a negative. Change that to a negative. Change that to a negative. T's go away. You're left with C equaling 15. And again, you define the variable so you know what C is. C is how much a crocus plant is. You need to find out how much whatever plant is. You need to plug that 15 in for the letter C and see what you got left. 4T plus 4 C's, which is 4 times 15, equals 104. This is 60, subtract 60, you end up with 44. 4 goes into 44, $11 for the whatever plant.